Welcome back. Good morning to you. In this video session, we shall continue our study of trigonometry. This is part 2. You can call it part 2. Here we shall talk about coterminal angles. So please, it is highly recommended that before you view this video, that you view the part 1. You know, the part 1 video, we talked about the introduction and concepts. Okay, and this is the continuation, part 2. Coterminal angles. So, what do we mean by coterminal angles? We mentioned it briefly in part 1. We say that the coterminal angles are angles in standard position. Angles in standard position. Okay. First of all, they are going to be in standard position. Then they have the same initial side and the same terminal side. Angles in standard position that have the same initial side and the same terminal side. So we're looking at angles in standard position, same initial side, same terminal side. Let's see what we're talking about. So when we have the circle in a coordinate plane, okay, when we have the coordinate plane, when we have the circle in a coordinate plane, and like we mentioned in the previous video, let's say we have this. Let's say we kind of have this a little bit, okay? This angle alpha, let's call this alpha. Alpha to be 60 degrees. Okay, let alpha be 60 degrees. Now, in this video, we're still talking about degrees. Okay, later we can talk about radians. But right now, we are still talking about degrees. Okay, now, this is the initial side that we talked about. This is the initial side. Let me use this color. Which is the positive x-axis, and this is the terminal side. Then this is going counterclockwise. So because it's counterclockwise, the angle is positive. Remember, we talked about it in the previous video. Before if it's counterclockwise, if the angle is formed by a counterclockwise rotation, then the angle is positive. Okay, let's now see another angle. Remember, look, it has from here the same initial side and the same terminal side. We can have another angle. Let me use here. I'm using this chalk. Okay, for the same initial side now, going clockwise instead. Okay, so you see that this angle has the same initial side and the same terminal side, but the only thing is that it goes clockwise. It goes clockwise motion. Okay, so because of the clockwise motion, it is negative. We say the angle is negative. Okay, let me ask you this first. What would this angle be? Remember that a circle, a complete revolution, when a circle makes a complete revolution, it is 360 degrees. Okay, that is angle in a circle, 360 degrees, or 2 right angles. I mean, four right angles. Okay, because this is a right angle, this is a right angle, this is a right angle, this is a right angle. So the complete revolution, the angle in a circle is 360 degrees. So what do you think that this angle would be? It's gonna be what? 300 degrees. Okay? But let's call this beta. Let's call it beta. I hope you're seeing this shot. You will see that beta is negative 300 degrees. Negative 300 degrees. Because it is negative because it was formed by a clockwise rotation or revolution. Okay? It was formed by a clockwise rotation. So we now say that 60 degrees and negative 300 degrees are coterminal. They are coterminal angles. That is what we say. Because they have the same initial side, the initial side starting from the positive x-axis, and also the same terminal side. Okay, some of you might say, okay, does it mean that it must always be positive and negative angles that are coterminal? No, it must not. I'm going to show you another example. Let's look at this. If I have, let me say I have here 20 degrees counterclockwise rotation, 20 degrees. Then from here, and also I can also have, look, I can also have do you see what I just did now? Do you see what I just did? I can also have that. Okay? So, what is going to be this angle? Remember, this is the same counterclockwise. So, both angles are positive. Let's call this angle theta. Let's call that angle theta, 20 degrees. Okay? And let's call the other angle now gamma. Gamma. What will gamma be? What will it be? You see, it's the same. This is this initial side and this is the terminal side. Initial side here, and then this is terminal side here. Terminal side here. Right? So, if you look at this, from here, making one complete revolution is what? 360 degrees. If it stops here, it's 360. Are you with me? Then plus 20. This is 360 degrees plus 20 degrees. So gamma is what? 380 degrees. So we say that 20 degrees and 380 degrees are coterminal. They are coterminal. So it must not, it must not always be positive and negative. It must not always be positive and negative. It could also be positive and positive. So you could have an angle and they ask you to find 3 positive coterminal angles. They can also ask you to find 3 negative coterminal angles. How am I going to find how am I going to find a negative coterminal angle? If the angle is negative, you know here, angle is positive, the coterminal angle here is negative. Here, angle is positive, the coterminal angle here is positive. Why don't I do negative, negative? And you see what I'm talking about. So if I come here, and I have this coordinate, okay, this is the initial side, okay. Now, let me have a negative, negative. So, from the initial, remember, it must have the same initial side and the same terminal side. So, let me use here. From here, this is clock clockwise rotation. Let me call this maybe 50 degrees. Let me call it 50 degrees. Okay? And then let me call this tau. Because it's a clockwise rotation, negative 50 degrees. Okay? Then, if I want to find a second negative coterminal angle, okay? Now here is the initial side. Let me write it with this because this is more sharp. This color is more sharp. Initial side, and this is the terminal side. Terminal side here. If I want to find another negative coterminal angle, then I come here. You see, it's the same initial side and the same terminal side. Now, this it's gonna be a negative. Okay, let me call this a side. Now, this will be one complete revolution, 360 plus 50. But it's going to be a negative anyway because it's a clockwise rotation. So, 360 plus 50, 410 degrees. So, we said that negative 50 degrees and negative 410 degrees they are coterminal angles. They are coterminal. If I want another one, I make two complete revolutions and come back to that terminal side. Okay, I start from the initial side and make two complete revolutions and come back and end on that terminal side and find that angle too. So you can list as many as close as you want to. Okay, so we've listed positive, negative. We've listed positive, positive. We've listed negative, negative. Why don't we do negative, positive? Negative, positive. Then we come up with a formula on how you can find this, because you don't really need to always draw this in order to find it. There's a formula for doing that to save you time. Okay? And before I do the next example, what do you notice, folks? What do you notice? Coterminal angles. This is quadrant 1. Remember, we talked about quadrant in the previous video. This is quadrant 1. The coterminal angle is also in quadrant 1. The quadrant is where the terminal side of the angle is. Okay, the quadrant. If you want to know the quadrant of an angle, what quadrant does an angle like? You have to find it where the terminal side of the angle lies. So this is the terminal side of the angle. 60 degrees is in quadrant 1 or first quadrant. This is the terminal side of the angle. Negative 300 degrees is in first quadrant. Remember, we said it like this. First, second, third, fourth. Okay? You can write it in normal, some textbooks will write it in Roman numerals. I, IV. Some textbooks will write it that way, it doesn't matter. So, you look at this now, okay, they are still in first quadrant. You see that? Both of them are in first quadrant too. Then you look at this, both of them are in fourth quadrant. So you know now that an angle and its coterminal angles are in the same quadrant. Because they have the same terminal side, they are in the same quadrant. Okay, you can write it down. An angle and its coterminal angles are in the same quadrant. Why? Because they have the same terminal side. And the quadrant of an angle is where the terminal side of the angle is. You can write it down on your own. Okay, let's look at getting a negative, positive, and see what it will look like. So, if we have let's say we have a negative here, let me say here, let me call this 20 degrees, okay? And I can call this rho negative 20 degrees because it is clockwise, okay? If I want to get the this initial side, and this is the terminal side, Okay, if I want to get the coterminal angle, but I want it to be positive, right? I have to start from the initial side, okay? Because that's a counterclockwise, which makes the angle positive. So let me call this epsilon, or let me call it alpha. Let me call it alpha. Oh, I've used alpha. Okay, I use alpha, beta, theta, rho. Let me call this psi. I'm sorry, I think I said this one to be psi. No, this is phi. This phi. This is phi. Okay, phi, and this is psi. Yeah, I think I called it psi. No, it's phi, and then psi. Okay, so this will be what now? Assuming I have this, what will it be? You start from here, 90, 180, 270 plus what? You can do 270 plus 70. Right? 270 plus 70 is what? 340. Or you can simply say 360 minus 20, 340. So this is 340 degrees. 340 degrees. So that tells you that negative 20 degrees and 340 degrees are coterminal angles. So we've covered, positive, 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 negative, 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 positive. Now, when they tell you to list 3 positive coterminal angles or 3 negative coterminal angles, you don't need to come and start drawing all these, drawing it. There's a formula for that. So that brings us to the formula, okay? So that brings us to what? The formula. We say that two angles, say alpha and beta, are coterminal in standard position, please. Two angles, say alpha and beta, in standard position, because we always want to make sure that this is in standard position. Remember, standard position which means that the initial side will be the positive x-axis. We talked about it in the previous video. So two angles, alpha and beta, in standard position. In standard position, are coterminal if beta is equal to alpha plus 360 degree times k. Okay? Where k is a positive or negative integer. Positive or negative integer. K is a positive or negative integer. So if you want to get positive coterminal angles, then you use K as positive integer. If you want to get negative coterminal angles, you use K as negative integer. That is the way it goes. Now, let's look at what I'm talking about. Let's see what I'm talking about. Let's say you have 20 degrees, like this one now, 20 degrees. Okay? Say you have 20 degrees. Find 3 positive and 3 negative coterminal angles. Coterminal angles. Okay. So if you have the 20 degrees, all you need to do is make alpha. Let the alpha be 20 degrees. Okay, let's find the positive first. Positive coterminal angles. Positive coterminal angles. So first beta, first one, beta will be alpha. In this case, 20 plus 360 times, in this case, let K be 1. First one, K be 1. Because if you, like I said, if you want to find the positive coterminal angles, you use K as positive integers. If you want to find negative coterminal angles, you use K as negative integers. So the first one, let me just write this first. First coterminal angles. First coterminal angle. Okay? Let K be 1. So beta will be 20 plus 360 times 1. So beta will be 20 plus 360, which is 380 degrees. And you see, that was what we found, the first one, 380 degrees. Like I mentioned earlier in this video, if you want to find the second one, you make another revolution and stop on the terminal side. That is the way you find it, if you're doing it from the diagram. Second coterminal angle, second angle, let's just say, second coterminal angle, we now say let K be what? 2. Let K be 2. So what would this be? This will be beta equal to 20 plus 360 times what? 2. So beta will be what? 20 plus what? 720, which is what? 740 degrees. 740 degrees. And then the third coterminal angle. Third coterminal angle, let K be what? 3. And we now say that beta will be 20 plus 360 times 3. So beta will be 20 plus 3 times 0, 0, 3 times 6, 8, carry 1, 3 times 3, 9, plus 1, 10. So beta will be 1100 degrees. 1100 degrees. So these are the 3 positive coterminal angles. Okay? Now let's go to the negative coterminal angles. Negative coterminal angles. First angle, remember, we say that if it's negative coterminal angles, then you make K to be negative integers. Okay? First angle, let K be what? Negative 1. So beta will be what? 20 plus 360 times negative 1. So beta will be 20 minus 360, which is what? Negative 340 degrees. Beta is negative 340 degrees. Then second angle, let what? Let K be negative 2. So beta will be 20 plus 360 times negative 2. Beta will be 20 minus what? 720. Okay? Plus minus 720. So beta will be what? Negative what? 700 degrees. Negative 700 degrees. First negative coterminal angle, second negative coterminal angle. And then third negative coterminal angle, third angle, let K be what? Negative 3. So beta will be 20 plus 360 times negative 3. Beta will be 20 minus what? 1080. So beta will be what? Negative what? 1060. Negative 1060 degrees. So you see that? And they are in the same quadrant, like we mentioned earlier. Okay? 20 degrees, 380 degrees, 740 degrees, 1100 degrees, negative 340 degrees, negative 700 degrees, negative 1060 degrees, all in the same quadrant. They are all in the same quadrant. Okay? And this is the same way you do negative angles. Assuming I say negative 20. If I have this as negative 20 degrees, say you have negative 20 degrees. Okay? What will you have? Let alpha be the negative 20 degrees. Right? So, if you want to find the positive coterminal angle, then your K should be positive integers. So, this will be K equal to 1. This is negative 20. Negative 20 plus 360. This will be what? Now 340 degrees. Okay? Let K be 2. You have negative 20 plus 720. And this will be what? 700 degrees. 700 degrees. Okay? This will be negative 20 plus 1080. Right? And that will be what? 1060. 1060 degrees. 1060 degrees. Okay? 1060 degrees. And then here, you still do the same thing. This will be negative 20. Negative 20 minus 360 is minus 380. Minus 380 degrees. Here will be negative 20 plus 360 times negative 2. Negative 20 minus 720. That will give us minus 740. Minus 740 degrees. The same way, it doesn't matter whether it's positive angle or negative angle. You just use it that beta is equal to alpha plus 360 degrees times K, where K is a positive or negative integer. If you want to find the positive coterminal angle, then you use K as a positive integer. If you want to find the negative coterminal angle, then you use K as negative integers. Then this one, K equal to negative 3, this is negative 20 minus 1080, and that will give us negative 1100 degrees. So, and this tells you that negative 20 degrees, 340 degrees, 700 degrees, 1060 degrees, negative 380 degrees, negative 740 degrees, and negative 1100 degrees are in the same quadrant. Okay? Angles and their coterminals are in the same quadrant. An angle and its coterminal angles are in the same quadrant. Now, remember, if the terminal, and that is where, because that is where the terminal, because they have the same terminal side, and the terminal side of an angle is what determines what quadrant that angle is. And then if the terminal side falls on an axis, either the positive x-axis or the negative x-axis, or the positive y-axis or the negative y-axis, it is a quadrantal angle. Okay, we'll stop here for today. Watch out for more videos, okay? Thank you for listening. And you have a great day.